Hello, my name is Ulf Hermann and I'm the maintainer of QML. I've been working on QML since 2019 and since then we've added quite a few things to the language. Mostly we've added warnings about things we don't want to use anymore. So today I'm going to show how to best use QML in Qt 6, how to write QML applications in a modern way that optimizes performance and that gives you best project structure, best maintainability, and makes your application safer. So this involves first setting up the project structure in the right way using our new CMake API. Then some aspects to take care of when writing components in QML. Then how to avoid mistakes. We have new tooling in place that can help you there. Then some aspects to take care of when writing components in C++. And finally, with all that in place, we can talk about our new QML script compiler that will be released with Qt 6.2.1, and that can compile QML script code to C++ directly, offering you a vast performance improvement if you're following the relevant advice on how to set up your project and how to follow best practices. Each of those sections, due to time constraints, will be somewhat short, but we've published various previous material, in particular my World Summit talk from 2019 and a recent blog posts on the CMake API and on how to register types declaratively in C++. And you can refer to those for more detailed explanations. This talk is going to be a high-level overview, like this is what you have to take care about, and in turn you get to compile your code with QML script compiler. And in the end, I will show a short performance comparison of code directly compiled to C++ with QML script compiler versus code compiled to bytecode with QML Cashgen. So let's dive right in. The first thing we have to do is set up the project structure. In Qt 5, you set up the project structure in a rather ad hoc way with QMake. You just listed all your QML files in a QRC file, which defined the resource file system, and then added the QRC file to your application like any other QRC file. And if you were lucky, you enabled QML Cashgen by adding config plus equals Qt Quick Compiler somewhere. And finally, you loaded your QML files, hopefully from the resource file system by prefixing your URLs with QRC : or by prefixing your file names only with : maybe from the host file system by just loading them from some place in your host file system, which would then make your QML Cashgen useless. Anyway, with our new CMake API, also released in Qt 6.2.0, you get a new CMake function to do all the QML module related things for you. It's called Qt add QML module. What it does is it enables QML Cashgen or the new QML script compiler for all your QML files and JavaScript files I have to add. It produces a target that automatically runs QML_lint on all your QML files, so that you can see without compiling what QML_lint has to say about your QML files. And it generates a QML_dir file that lists all your QML files with all the right attributes. And this is in contrast to QMake, where you have to write your QML file manually and make sure that all your QML files are in there. It also generates a QML types file, so it replaces what you would previously do with QML plugin dump. It generates the QML types file at compile time without loading any plugins, as QML plugin dump does. So it's much safer, and it generates a much improved QML types file that is really useful for all our tools, for Qt Creator, for QML_lint, for the new QML script compiler. It will also be used by the new language server. It allows mixing QML and C++ modules. This was also possible in Qt 5, but somewhat complicated to do due to the question of where those modules would be loaded from and what would be in them and what would be outside them. This is all taken care of automatically now. You just list your files, and Qt add QML module makes the module available in the resource file system, and it also makes it available in the host file system so that you can load it by plugin. It also keeps all the files in the host file system for Qt Creator and QML_lint and other tools to see, while also making all the QML and JavaScript files available in the resource file system so that you can load them and take advantage of the ahead-of-time compilation. In the future, we'll add more options to those two aspects. For example, strictly speaking, you could skip the QML source code in the resource file system if the module was compiled ahead of time and you know that the Qt version hasn't changed. So there will be an option to do that at your own risk. And furthermore, we don't necessarily need the source code in the host file system if no other module depends on the module in question. So we might also add an option to avoid that. So let's look at the details quickly. This is an example CMake lists txt file that defines a QML module with exactly one QML file. It defines all the boilerplate, like minimum CMake version, the project name, what packages we need. Obviously, we need QML and Qt Quick. One important thing is CMake AutoMock. That is necessary to analyze your C++ files and check them for any QML-related macros with mock. And then, with all that in place, you call Qt add QML module. You pass it a URI, a version, a resource prefix, and QML files. So we are going to talk about those things separately. First, the URI. The URI is the name of your QML module. I'm going to use these terms interchangeably going forward. So if I say module name, I mean the module URI and vice versa. The URI has to be different from the executable name. That's to be noted, because otherwise we get name clashes in the build directory. We might resolve that in future versions of Qt. The URI finally is the thing that that determines how to find your module. If you want to import the module from elsewhere, from a different QML file, this is the name you have to give to the in the import statement. The version is of less significance. Actually, we are probably going to get rid of it in the future. You should not use versions anymore in Qt 6. So in all your QML files, it should just say import some module without version appended to it. If you do use versions, then the version argument here might be important. For now, you just have to state some version for historical reasons, and we will probably make that optional in the future. The resource prefix is the place in the resource file system where your QML modules are generally installed. So your application might have multiple QML modules, and you should always pass the same resource prefix, because then, as we will see, you can set up the resource prefix as QML import path, and all your QML modules will be immediately found in the resource file system. So this is not the place where the module is in the resource file system as where all the files are. Rather, the URI is appended to the resource prefix, and that results in the path where your files are installed. This is so that there's space for other modules too. Finally, we have the list of QML files. I have to say this is not only QML files, but also JavaScript files. Basically any QML and JavaScript code that belongs to your module. Those files will be analyzed by QMLint if you call the relevant target, compiled, and copied into the right places. And copied into the right places means in the resource file system as well as in the host file system, so that the tooling as well as the application can find them when needed. One thing to be aware of is you should not use the well-known Qt add resources CMake function, because that one will just add things to the resource file system without doing all the extra stuff that Qt add QML module does. So your files will then not be analyzed by QMLint. They will not be compiled ahead of time, either by QML Cachegen or by the QML script compiler. And crucially, they will not be made available in the host file system for Qt Creator or QMLint or the QML script compiler or the future QML language server to look at them. So do not use plain Qt add resources. Always use Qt add QML module. With that in place, we can take a quick look at the entry point C++ file, your main function. One thing to notice, do use QQML application engine. This is more convenient than QQML engine. It automatically translates your translatable strings in the right languages. It does auto quit on when calling Qt quit in QML, so you don't have to connect any signals for that. and it just works. The more important thing to note here is what I've briefly stated before. The best way to load your QML modules is from the resource file system, because when loading from the resource file system, it does not have to search the host file system, which can be slow depending on what file system you have. It does not have to load any plugins. It just checks in the application binary itself, where it finds the resource file system, and if the module is there, where it will be if you've used QML module, it loads it from there. So what you do here is you set up your resource prefix to be a QML import path. Finally, you load your entry point QML file. Our project only has one QML file so far, so that is the entry point. You should always load it from the resource file system. Do not load it from the host file system for the same reasons as stated above. Won't be compiled, will result in plugin loading. Not a good idea. So with basic project structure in place, we can take a look at writing components in QML. When writing components in QML, the main theme of everything we do is be explicit. Allow the compiler to see what you're doing. Allow QMLint to see what you're doing. Allow Qt Creator to see what you're doing. Because then you get better diagnostics, you get better performance, and you make your project more maintainable, because the IDE can give you better hints on what certain things are, and better auto-completion in the future when the language server is in place. And everything I've listed here is part of that theme. First thing is avoiding var properties, because var properties are untyped. We never know what's in them. The second thing is avoiding implicit lookup in the root scope, because such implicit lookup can be shadowed by various unrelated things. Third is avoiding using type annotations on functions, so that we know what types are passed into those functions and what types those functions are returning. Then we should avoid duck typing where possible, and we prefer IDs over properties. Now about var properties. The first thing to note on this slide is that we call QMLint with a special option, compiler equals warning. I do that throughout the whole presentation, and that is because QMLint is somewhat conservative in its warnings by default. We have this extra compiler category where it outputs the same warnings as, well, almost the same warnings as the QML script compiler does. This is most useful if you're going to compile your code to C++, your QML code. It might generate somewhat cryptic warnings, as you can see on the right side here. This is because the QML script compiler is still tech preview, and the type inference mechanism we are using for the script compiler, as well as for QMLint's compiler warnings category, has still some quirks. However, those warnings may still be very useful if you just want to know what places in my code need improvement. And if you don't understand something, you can postpone fixing that to a future version of Qt when the warning will be clearer. Or you can write a bug report and I will probably fix it. But I'm talking about QML-lint with this warning category enabled throughout the whole presentation. You can write a configuration file for QML-lint and globally enable this category so that your QML-lint targets will output the same warnings. Now, back to the var properties. On the left side, you see a Qt Quick item, which has a property untyped self, which is, well, untyped. It's a var property. We see that it actually holds the same item, self, and the same item is a Qt Quick item, which has a property x. So we can read that property x and assign it to another property a, which is an integer. This will generally work at runtime. However, any tooling cannot prove that your untyped self var property will always hold an item, because some other code anywhere else basically can reassign this var property and put string in there or font or whatever you like, because var is untyped and you can put anything in there. And then the binding on a, the property a, will fail with a type error or silently, depending on when and where the assignment happens. QML-lint wants as much. It says it cannot compile the binding for a, and that is because it doesn't know where that x property is coming from. I have to admit that this warning is somewhat cryptic, but you see it cannot load the property x, obviously. So we have to do something about that. What can we do? Well, we can be explicit. We can say the thing we have there is actually an item. So we have a property item typed self this time, and it holds our item itself. Then we know, okay, item does have a property x, and the property x is numeric, so we can cast it to an integer, and QML-lint will be happy. Now, if some other code went and assigned some other thing to type self that is not an item, that will fail already. So type self will stay an item no matter what you do with it, and this code will always work. Therefore, the resulting component is not only easier to compile and easier to analyze, it is also safer. The properties that you're looking for in this component are guaranteed to exist. Now you might ask, okay, what if I don't control this property? Say I have this property item. I know that it actually contains a rectangle, but let's say someone else wrote this component and I can't change this property item. We cannot see that in this example because it's in the same file, but say there's some contract to it, it has to be an item. Type self has to be an item, we cannot change it. We still want the rectangle's radius here. Well, at runtime, that's easy. We just access property radius. This will work generally, unless you assign something to type self that is not actually a rectangle, then this will fail. You might even assign something that is a rectangle but has another property radius on top of it. That will do interesting things because then it will read that other property. And QML will warn as much. QML says, well, what we have here is a QQuick item, and that thing does not have a radius. So what am I going to do with this property int a here? Now, given that we cannot change type itself, what can we do? We have to change something about the binding on a. There's a solution to that in Qt 6. It doesn't exist in Qt 5. And that is the ascast, as borrowed from TypeScript. Mind that it does behave somewhat different. You can state, okay, this type itself here is actually a rectangle, and now get the radius from it. In contrast to TypeScript, this will give you a null if the thing is not actually radius. In TypeScript, it would give you the original value, so it would give you the item if it's not a rectangle. The result of this is we can be sure that the radius property exists on the resulting type self, and crucially, that the radius property is actually the radius property of rectangle and not of some other type. The QML script compiler can then use this information to directly access the radius property. It does not have to go through the type hierarchy and see, oh, might there be some other property called radius, and to check if the element in question actually has that property and so on. No, it knows this is either null is handled separately, or it is a rectangle. And if it is a rectangle, bam, give me the radius property. So QML is happy with this. Another thing, one thing I've talked about before already, arguably the most important change in Qt 6 is you should not do implicit lookup in the root scope of a component. Now again, look at on the left side here, you have an item with the property offset. And nested inside it, there's another item that uses this property. In QML you can do that. You can just type offset there, and it will look in the root component in the root element of the component and take the offset from there. However, there is a vast problem with this. First thing is, we are importing QtQuick without version here. So if some future version of QtQuick added a property offset to item, and it's not important. It's not impossible that this might happen, right? Then it would not take this offset property from the outer scope anymore, but rather from the inner scope. So the same QML code would silently misbehave if you just upgraded a dependency, namely QtQuick. Now this is certainly bad. This is the whole reason why versions have been introduced into the language itself. So we want to avoid that, because versions are a whole huge can of worms which we've never managed to fix in Qt 5. So we are going to avoid that. And it will also help the compiler because it can then see where this property comes from. Here, you cannot see from the document itself where the property comes from. It could be the property offset, or in a future version of QQuick, the offset member could be added to item itself. Too bad, then your code won't compile anymore, or will misbehave. Even worse, it will misbehave when run. Or it could be a context property, because context property also fit in interesting places into this lookup hierarchy. So let's just not go there. Let's make it explicit. We mean the property offset of the root item of the component, and we don't mean anything else. Here we go. We give the root item an ID, and we say, okay, it's the offset of the root item. Now it's totally clear. We don't have to search for it anymore. We don't have to check, oh, is there maybe a context property? Is there maybe some parent item that might have it? Well, not parent, but root item. Or might there be another property, an item that is called offset, etc., etc.? No, we just know. We know this is the root element's offset, and QMLint will be happy about it. Another aspect, when adding a function to your component, JavaScript allows you to add, or JavaScript forces you actually, to add a completely untyped function, like shown here. This add function adds A and B. Now, if you know a bit about JavaScript, you know that this plus operator, depending on what the types of the left-hand side and the right-hand side are, does interesting things. For example, you can easily add a string and an array or an object and a number, etc., etc. You can pass in whatever you like to the add function, and it does something. QML script compiler does not support that. QML script compiler only supports a subset of those add operations, and it requires you to state what types you want there. So QML script compiler will only compile functions with type annotations. Type annotations, again, are borrowed from TypeScript, and they look like this. Here, we've stated that both parameters to our add functions are integers, and the function also returns an integer. With this in place, QML script compiler knows what plus operator we mean here, and it can generate very efficient code. Much better code than JavaScript will generate, or much better code than interpreter in JIT will generate. And QMLint is happy about it. Finally, we prefer IDs over properties. Now, let's go back to our funny radius example. Here we have actually shadowed the property radius on rectangle. This is a bad thing to do, by the way. But let's say we have such a component that shadows the radius property. So it has a property that's not a number, called radius, and we have an item in there that actually uses this property. The item we see there relies on the parent property of QQuick item. Usually, the parent is the item that directly surrounds the one in question, so the rectangle in this case. Yet, this is not guaranteed. You can reparent an item. You can give it any other object or QQuick item as parent. And those other QQuick items might not have a property radius, right? So the compiler or QMLint cannot actually prove that this radius property we are looking for here is actually there, or neither can it prove what type it has. So it cannot compile this binding. And that's basically what it tells you there. You cannot compile the binding for R because property radius is not available on QQuickItem. Yet we can fix this. Here we are not reading the property radius from the parent property of item. Rather, we are assigning an ID to the element we want to read the radius from, and then we read the radius from that. The upside here is an ID is a unique thing. Each ID can only be given once in a QML file, and the element referred to by an ID cannot change. So once we know we want the property radius from this root element, we know it's this string radius and not anything else, because there cannot be a different root anywhere. Well, there can be more IDs root in other files, but not in this one. And so we can be sure what property to read when asking for radius. This way, the QML script compiler will be happy with it. Now here's the general workflow on how to avoid those mistakes. CMake, when run on a target with Q.QML module, gives you a QMLint target for each such module. Then you run this. You get warnings from QMLint, and you may want to fix them. Furthermore, you can configure QMLint to warn about the compiler category. In the future, we will integrate this functionality into the new language server and also into Qt Creator's code model, so that will be even more convenient to see and even easier to fix such things. Mind that QML script compiler in Qt 6.2.1 is still a tech preview, and so we haven't enabled all those warnings by default in QMLint yet, and they may still be somewhat cryptic. This will change in future versions of Qt. Now that we've fixed all our QML components, let's take a look at the C++ defined QML components. How do we deal with them? One thing to do when writing components in C++ is declare them as such, declare them as QML exposed types in their headers. For that, we have a collection of macros you can use alongside the QObject macro to configure various things about the resulting QML component. The most prominent one is QML element that simply says this type shall be exposed to QML. In turn, you should then avoid QML register type and this whole family of functions. QML register type and similar functions have to be called procedurally, and at compile time we cannot see where you call them and with what parameters. Well, we could see it by analyzing your C++ code, but you can probably guess what kind of can of worms that would open. Qt Creator actually tries, but we are not going there with our new tooling. Then, in order to avoid shadowing, as we've seen with the radius property before, you should make all your properties final. And finally, in order to allow the QML script compiler to generate optimum code, use QProperty. QProperty is our new C++ based implementation of bindings and properties, and that's vastly superior to the old way of defining properties. Now let's look at the individual points separately. The first thing is QML element. You can look at my blog post about this. There's a whole litany of things that you should be aware of there. The most important one, however, and the one that takes you a long way already, is just add QML element. Just add QML element to the types that shall be exposed to QML. What happens then is mock picks that QML element up and generates JSON type descriptions from it. QML type registrar reads those type descriptions and generates type registrations and QML types files from it. The type registrations are basically a C++ file with a number of QML register type in it. Now those are generated, so we don't have to analyze them anymore. We have analyzed your macros before. And the QML types files, finally, are used by various tools, QML-lint, QML script compiler, the QML code model and Qt Creator to give you hints and to compile your code, your QML code. And the nice thing about it, if you use Qt.QML module, it's all automatic. You don't have to adjust your build system for it anymore. It all works just like that. Now conversely, what should you avoid? Any explicit call to QML register type or QML register anonymous type or QML register uncreatable type, etc., etc. Do not do this. Our tooling cannot see those calls. They will result in interesting warnings from QML-lint, and QML-LC will reject your QML code that relies on such components. You're not doing yourself a favor. There's a replacement for each QML register call. Each of those has a macros replacement. Then, in order to allow QML script compiler to generate optimum code, you should make all your properties final. How do you do that? Well, the first thing to do is really simple. Just add an attribute final to your Q_property. Final properties cannot be overridden by other properties in derived types, neither in C++ nor in QML. So, when we access a final property in QML, QML-lint and the QML script compiler can know what property we are actually accessing. It knows that this property cannot be overridden by any derived type. It knows that it can directly call the read accessor here and get what you're looking for. Conversely, if a property is not final and the script compiler cannot prove that the type you're reading from is exactly the type it knows and not some overridden, some derived type, it will not generate any code to access this property. It will just reject this function. So do declare your properties as final. And finally, use QProperty. QProperty is our new way of defining bindings in C++. This is basically, we took what we learned in QML. Properties and bindings are a very nice way of writing applications, and we made it available in C++. Now QProperty can track dependencies automatically. So if you attach a binding to a property and in that binding you read a different property, the binding will know it has to reevaluate when that property it has just read changes. This is very nice. It saves you a lot of boilerplate code of setting up signal and slot connections. But it has another effect. Previously in QML, if you read a normal property without bindable, without QProperty, and that happened in a binding, like all our QML functions basically are, then the QML engine has to keep track of the binding and its dependencies. It has to do all the bookkeeping. So from generated code, if QML script compiler generates code for that binding, it has to call into the engine and say, hey, please register, we are reading this property. If the property changes, please call us back. That has a certain overhead. If the property is a QProperty, it doesn't have to do that, because the QProperty itself will register the dependency. And the QProperty itself will have the binding re-evaluated. So that saves us a lot of overhead, and it makes the resulting code a lot faster. Now I've talked a lot about compiling to C++ on the side. It's time to give this a proper treatment. So let's first take a look at the history of compiling QML to C++. Since Qt 5.10, we have QML cachegen. That's our current way of doing this. And it does not actually compile to real C++. It compiles your QML script code to bytecode. That's the same bytecode it would generate at runtime. It just does that ahead of time during compilation. This mostly saves on the overhead of loading a QML file. It does not do much about runtime performance, like the speed of evaluating properties and bindings. The bytecode is then wrapped in a C++ file and packed into the application binary. Until Qt 6.2, until Qt 6.1, this had to be enabled manually. From Qt 6.2 on, this is automatically done by Qt.qml module. It will just call QML cachegen on all your files. From Qt 6.2.1, we have a tech preview of the QML script compiler that compiles QML script code into actual C++, not only bytecode. This is then compiled by the native C++ compiler into the application binary, and it's also enabled automatically by Qt.qml module. Now the difference is the bytecode is still interpreted by the interpreter or the JIT at runtime, And this has an overhead. Interpreter always has. With QML script compiler, you get a natively compiled function. And we just call this function instead of interpreting or JITting. This is faster most of the time. Now the plan for Qt 6.3 and onwards is some aspects of QML SC will move into QML Cashgen, and we get another compiler, the QML type compiler, that compiles the QML object structure to C++. But I'm not going to talk about the details of that today. Now the basics of the QML script compiler. As said before, it compiles QML bindings and functions to C++. It is drop-in compatible with QML Cashgen. The added functionality of it, in contrast to QML Cashgen, understands a subset of the QML language. So that means certain parts of QML, like implicit access to the root scope of a component, it will not understand. And for bindings that do that, it just generates bytecode. That's the fallback to QML Cashgen behavior on code it cannot compile. It will also output a warning on that. For code it can compile, it generates a year C++ function in addition to the bytecode. You can then still pass the relevant environment variables at runtime and have your application revert to bytecode interpretation. As a tech preview in Qt 6.2, it may be buggy, it may reject your code for no reason, and it may eat your cat. So be a bit careful, but your cat may just survive and your code may be faster, and you can prepare for future versions where it's not in tech preview anymore. Regarding licensing, a few more things have to be said. As mentioned before, it's a tech preview in Qt 6.2.1, and for now it's only available for Qt for device creation. Some of this will change in Qt 6.3. The base technology of it will be dual licensed, and it will extend QML Cashgen. So in the future, with QML Cashgen alone, you will get some compilation to C++. How do you obtain it today? You find the extra package in the Qt installer. If you have Qt for device creation, you install it, and that's it. You're done. Because the Qt build system will automatically pick it up and use it in place of QML Cashgen. Now, in addition to the base functionality, QML script compiler also has a direct mode. This is what I was talking about when detailing why QProperty should be used for defining your properties. In direct mode, QML script compiler can access members of C++ types directly. So if you have a QProperty with bindable, it can directly read that. In indirect mode it can't, and we'll see why. This is then faster than access to the QML engine, which it does in indirect mode, but it requires the C++ type that it's reading from to be available to the generated code. And this requirement has quite a few consequences. First, it needs to include the header where the property is declared. And that should include the read accessors, the write accessors, the bindable accessors. Then symbols for that C++ type have to be exported if the C++ type lives in a different binary. And finally, the library possibly it lives in, for example Qt Quick, has to be linked into your QML module. In effect, you need to use Qt's private API for direct mode because most of Qt's QML types are in fact private in C++. Like QQuick rectangle lives in a private header, QQuick rectangle _ph, and you don't get to use that unless you use QQuick private. Now that's certainly a downside because you don't get to benefit from all of Qt's compatibility promises then. And you have to recompile your code with every version of Qt and stuff might break. However, the QML script compiler only uses a narrow subset of this private API. It only uses the properties exposed by QProperty. And those are actually governed by our QML compatibility promises. So you can still be pretty sure that the generated code will still work. You just have to recompile because we don't guarantee binary compatibility between versions of Qt on private API. Now for those downsides, you get a substantial performance benefit that we'll see in a minute. In addition to static mode, we will introduce another mode in Qt 6.3 where the shadowing problem is solved. Basically in Qt for MCUs, if you've used that before, you might know there is no shadowing. No properties can be shadowed in Qt for MCUs, and if you're coming from Qt for MCUs, we can make use of this property. We can say, okay, no properties can be shadowed, and we just assume that all properties are final. Then we can compile a lot of further bindings. There are other semantic differences between QML and Qt for MCUs, and with static mode, QML script compiler will aggressively take advantage of those to generate better code. Some of this already exists, but not in the tech preview we're publishing with Qt 6.2.1. So you'll have to wait for Qt 6.3 for that. How do you configure QML script compiler? Well, the basic thing is you don't strictly have to configure it at all. The build system will use QML-SC if available, and otherwise it will fall back to QML Cashcan. You will want to switch on direct calls if your code is ready for it. If you've made all your C++ types available, used private API, and linked all your libraries the right way, and that's done with a target property. Qt QML Cashcan direct calls on. In the future, you may enable static mode. This has to be done with generic arguments property for now. And you can nail it down to use either QML-SC or QML Cashcan explicitly and fail if that doesn't work. That's what the Qt QML Cashcan binary option does. Note, this option is going to be renamed in Qt 6.3. It will be Qt QML Cashcan executable. That's part of the tech preview status. So with this, you can force it to use QML Cashcan if you find a problem with QML script compiler. Do please report the bug, please, and then I'd like to fix them. You can also make it explicitly use QML-SC and fail compilation if QML-SC is not found. That may be useful to make sure that you've actually installed it. Now, let's look at the performance. Here's an example where we calculate Fibonacci numbers on the width and height of items, QQuick item. This is a nice thing for the script compiler because width and height are both already converted to QProperty. And so reading them and writing them gives us the optimum code path when compiled to C++. Furthermore, we are doing all of our calculations modulo some configuration boundaries, some configured boundaries, and those are enums in QML. The enums are another aspect where the compiler helps a lot with performance. So what we do now with this code is we have 10 such items in a row, and we toggle the width and height of the first one, so that all of the chain of bindings that follows is reevaluated with each step. And then we count how many such iterations we can do within a second. And here's the result. With QML Cashcan only, we can do about 375 iterations per second. In indirect mode, we can do about 440, and in direct mode, we can do about 540. This is because in indirect mode it cannot take proper advantage of the fact that the width and height are QProperties. So what you see there is mostly the effect of resolving the enums at compile time rather than at runtime. In direct mode, we get a vast performance increase due to the effect of directly accessing the QProperty members. Mind that this benchmark was done on dev, on current dev. In 6.2 it's still somewhat slower because QML script compiler is still missing some optimizations that have been added since. Now, if you have any questions, I'm happy to answer those. I'll be in the speakers lounge for the next 30 minutes and I'll be happy to meet you there. So thank you for listening and see you.